This video demonstrates two applications of linear inequalities. The first example relates to a course average which is based solely on test grades. The problem reads, to earn a B in an algebra course, a student must have a test average of at least an 80. Drake has grades of 85, 76, and 72 on his first three algebra tests. What minimum score does Drake need to make on his fourth test to earn at least a B in his algebra course? The unknown in this problem is the score that Drake needs on the fourth test. We will let X represent the fourth test grade. We also know that he wants an average of at least a B. This means that the average of the four test grades must be greater than or equal to 80. So to answer this question, we solve the inequality formed by setting the average of the four tests greater than or equal to 80. Recall that to find the average, we add up the four test grades and divide by 4. This gives us the expression 85 plus 76 plus 72 plus X divided by 4 is then greater than or equal to 80. Simplifying the numerator gives us 233 plus X divided by 4 is greater than or equal to 80. Now we multiply each side by 4 to clear parentheses. This gives us 233 plus X is greater than or equal to 320. Subtract 233 from each side. To get X is greater than or equal to 87. So recall that X represents the score of the fourth test. Therefore, Drake needs at least an 87 on the fourth test to earn at least a B in his algebra course. The second example illustrates a weighted average. It states the final grade in an algebra course is based on a weighted average. Homework counts 20%, quizzes count 15%, tests count 40%, and the final exam counts 25%. Tanya has a homework average of 73, a quiz average of 75, and a test average of 68. What score does Tanya need on the final exam to have at least a 70 for her final course grade? The unknown in this problem is a score on the final exam. We let X represent the final exam grade. We want to solve the inequality. Final course grade is at least a 70, or final grade is greater than or equal to 70. To represent the final course grade, we use the given percentages. Homework counts 20%, quizzes count 15%, tests count 40%, and the final exam counts 25%. This means that 0.20 times the homework plus 0.15 times the quizzes plus 0.40 times the test average plus 0.25 times the final exam grade represents the final grade. We substitute the known values to get our inequality. We get 0.20 times 73 plus 0.15 times 75 plus 0.40 times 68 plus 0.25 times x is greater than or equal to 70. Simplify on the left, and when we add those terms together, we get 53.05 plus 0.25x is greater than or equal to 70. Now subtract 53.05 from each side to get 0.25x is greater than or equal to 16.95. Divide each side by 0.25 to get x is greater than or equal to 67.8. This means that Tanya needs to score at least a 67.8 on the final exam to have at least a 70 in the course.